crazy, berserker. I killed it, it's murder. Go 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 crazy, berserker. Crazy.
Some form of control still, making our constant binary choices and voicing our equally shallow opinions more loudly or quietly. Most people can't even decide what color to wear or which burger to eat. What does it matter, man? Autonomy is an illusion. Autonomy is an illusion. Most people can't even decide what color to wear or which burger to eat. What the does it matter, man? Autonomy is an illusion. Autonomy is an illusion.
Hello everyone, back for Monday, doing some binary exploitation practice, going right back to the Nightmare course, and continuing on with the ROP series. We'll see if we can get more than just one of them today. Switch over to that screen. So last time we went through and we just did stack stuff, I believe. Oh no, we did I can count. We finished that one up with anger and then did stack stuff. So this time we're gonna continue on to Pwn 2 and maybe Volchat 2. This one is from Tamu CTF, I guess. 2019. I don't know what Tamu CTF is. Texas A&M. Yeah, cool. And these are both in the partial overwrite category. Same with hack.lu stack stuff. So we have the ability to overwrite some portion of return address, or perhaps in the style of the stack stuff, we can overwrite a couple of complete return addresses, but then a portion of an address. And the fact that we can overwrite just a portion of an address was what allowed us to skate by the lack of a leak for the base address of the binary itself, or libc, or anything else. So we did have to write a couple of actual return addresses that we were able to get from the vsyscalls, the old style virtual syscalls mapped in area, because that is mapped into a static address range. I had never thought to do that, and so I had to check the walkthrough on it, but now that I know that's a thing, I hopefully will remember the next time it comes up. And so we were able to use a couple gadgets from there and just override a portion of the low 2 bytes of an address that was already in memory, returning to somewhere within the text section for the binary itself. So then we could modify slightly where it returned to, and we were able to get that going. So it might be that we're in the same scenario with this Pwn 2 challenge. I've already copied everything in, so let's just take a look at it. So it's a 32-bit ELF. It's dynamically linked and not stripped. That's helpful. It's linked just to libc. And let's see what the security settings are. So full rel row, no canaries, that's going to be helpful. NX is enabled, understandable, we're in the ROP section. And PIE is enabled, so if we have to leak something, then we have to leak we either have to leak something, or we're doing a very similar approach to what was used with hack stuff, where we either have just enough to overwrite the low bytes of the original return pointer, the one that's the return address for the function that we're in, or we can go past it and there's some address that's at a fixed location, which I think would only be the virtual syscalls, the old style one, but maybe there's other ones that I don't know about. We can look at it in VMMap and GDB at some point. So let's go ahead and open it up in Radar. See what we got. It's not stripped, so that's going to be helpful. Sim.main. Okay, do the thunk for EBX. We set probably no buffering mode. We put something and then we call the fun little gets function, everybody's favorite. And that's going to get to EBP minus 27. So we can overflow from there. And then it passes that to select func. So let's see what select func is about. And we also have local 8, which is interesting. That gets moved into ESP. And then we pop things. And then, so I don't know what this would be about in terms of a normal application. It's maybe there's a good use for it, but my first thought is we can definitely overflow to this, right? In fact, even if there was a canary on this, we could overflow from the buffer at EBP minus 27 to the 4 byte, the D word at EBP minus 8. And that would load ESP, which then controls what we are popping to ECX, which is then used as the new value of ESP, and that's what we return to. So that's interesting. Obviously, we'd have to have leaked some addresses to know what we could put in the overflow value at local 8. In fact, in order for us to overflow at all, we will need to know something, because if we want to overflow to the return or whatever, yeah. So, I mean, I guess that makes sense, right? We always need to have some address that we know about, and with ASLR and PIE, we are not in a position to do that unless there's a leak, which might be the puts up here. Let's look at select func. Okay, we do a string copy. So real quick, the one parameter to it is pointer to our stack buffer that we have just written into with gets. And that's our arg8. Okay. We are storing some value from a fixed address in the data segment or something into local C, which we call down at the bottom. So that's interesting. Yeah, okay. And let's see. So move EAX into there, and then later we do a string compare, and if they are equal, then we load a different address, and that's what we will call instead. So these are two functions that we will call just through indirection, 190B and 1864, and we can go ahead and work out what those are at some later point, I guess. First we do a string copy from our argument to 2A. So this one is so we can definitely overflow this buffer, right? And we can overflow it in a way that results in an overflow in select func as well. But the problem is if we overflow enough, so this is going to be 1F, I think 1F bytes, so what, 31 bytes, 30 characters plus the null byte maybe is what it's intended to store. And we could overflow that, but then we're going to overflow into EBP -8, which determines the ESP stuff that I was talking about a little bit earlier. So that really impacts on how the main function quits. So we got to be careful about overflowing that, but we can, if we overflow it by by 4 bytes, I guess, because this is the same 1F, I think. Or is that, it's 1E? Ooh, why am I? Yeah, it's 1E in this case. Is it the same? I guess. Let's see. Oops. No, it is 1F there. Okay. Oops. Didn't want to do that. Okay, so if we overflow by 5 bytes from what the original buffer was, then we can control what's in local C, and as long as it doesn't do a string compare, or it doesn't succeed the string compare, so if it's not equal to whatever this fixed string is, we can come down here and it will call our function. Or rather, it'll call the address that we have input. The problem is then we still need to, know something. So maybe this first puts will leak something for us. Of course, it's a call to puts, which is a fixed string, and how would that fixed string know what our address is, basically? So I'm imagining that puts doesn't actually leak anything for us. You have, this is function 1, that's probably what it is. And oh no, these are probably one of the 2 functions that you are allowed to call. Let's see. Okay, so we have main, we have select, 1, 2, and print flag. So interesting. I'm not sure what the string compare here is. Let's go ahead and run the program. Which function would you like to call? It's going to be, I guess, the first puts. So that's this address. So, I mean, I can only assume that's what's puts here. So EBX minus that value is equal to this. So plus 1670 gives us 1FB8 as the base, or as the value of EBX rather, which I guess would be the base address. So copy that, and then we go into select func, and let's see what we're comparing against here. Minus 1675 or so that's the string 1. Okay, so we type in 1, then we'll get this function. If we type in 2, we get that other function. So this is function 1, yeah. Okay. How do we... Well, okay. So if we simply overflow a little bit into ECX, if we can figure out the difference between function 1 and, or sorry, function 2, because I think this is going to be 2. Is it just copes? Yeah. So that's at 6 AD, and let's do just AFL. Okay, so 190B versus 1864. 2 is at 6 AD and 1 is at 754. So let's do what do we want? 17 BD, or I guess we want to add it. Yeah. Okay, so function 2 is the one that we need to figure out the difference with. And it's actually pretty small. So the low bytes are going to be 6 AD, or the low 1.5 bytes are 6 AD, and we want to change it to 6D8. But much like the previous one, we still have a half nibble that we have to guess, and that could be any of 16 values. So we can go ahead and just write the same kind of loop until it works, kind of deal. And yeah, I think that's reasonable. It's going to print out the flag, and then we're going to have a weird situation because we will have also overwritten this value. So this stuff might crash here, but I don't know what we can do about that, to be honest. As long as we've printed out the flag, the fact that the program crashes after that, it probably doesn't matter. Is that? No, I think it's from home import. Okay. What do we call this one? Prone 2. And then okay, so we'll get those two functions, and I guess we don't even need this, right? we just want to say our payload is A times, so I think it's 1F. P16 of print flag adder and the low bytes of that. Let's see. I think it's, oh, but that's a problem, huh? Because we're gonna have a null byte at the end of our buffer. Oops. No. Typed it wrong or something. So it's going to do a string copy, strn copy. Oh, okay. It's only going to copy. Wow, I somehow missed that. It's only going to copy 1F bytes. So it's actually not going to overflow this buffer. Shit. How do I? Oh, no, that's what we want. I think. What happens with string copy if you hit the size? Will not be null terminated. That's a nice warning. That probably should be a louder warning. Okay, so that's good. So we can provide that many bytes. It'll null terminate it in the gets call. And so we'll actually be writing 1F plus 3, so 22 hex bytes, which is writing 4 bytes, I think. Oops. Right, 1E minus, or 22 minus 1E. Yeah, so we are writing the full 4 bytes of local 8, because it's only 1E before we start overflowing local 8, and if we write 22 total, that's going to be 4 bytes. So we're writing all the way up to the beginning of local 4. But again, I think it doesn't matter if the program crashes after that. So we'll send just that payload as a line, and then I don't care about decoding it. Alright, I think that's everything we need. Oof. Well, first off, it is seg faulting, which is understandable. I guess I am not necessarily seeing the... I always forget to do like... log level. Why is that? Info needs to be error. That's what I was meant to do. Okay, so I think we are probably not hitting the condition that I expected us to be hitting. So let's run it in GDB and see what we can find. I really should like come up with a pre-built thing with my debug logic in there, because that was helpful on some previous challenges for sure. $28.65 and what do we want? Select func. Okay, so we're going to put the breakpoint at select func plus. Let's put it on the strn copy call and be able to see what all is going on. Okay, so what we have on the stack is look at this address as a string. What? Can we save that? No? Okay. Cannot access the memory at that address. Let me make sure that I am understanding it right. Yeah. Do I need to put in the pointer to the pointer? No. Oh, I copied the wrong thing though, right? Or, no, that's the right thing. So why can't we access the memory? Yeah, why has that failed? Weird that no, it's 2880, and we want to set this breakpoint and continue. So why does that break? 1A, 2, what? Okay, it is segfaulting somewhere inside of strn copy. But what would be... And they're not like close enough together to be overriding themselves. So that is confusing. I guess let's walk through strn copy. No, it aborts right away. Like what? What the heck? What is possibly the problem here? How in the heck is that call causing problems? Did it not segfault? Okay. So, it's at this address, not, so it's at 641. So what is that? What function is this? This is... So not print the flag, but I mean this would be, I would think, a function that comes after string copy. Because this is in register TM clones. I don't really, I mean it's one of these like standard libc boilerplates, but I don't know what it does really. And why are we at 641? Like how did we even... I mean obviously 641 is, I guess it's the address we were writing, like oops, okay, so no, we are writing 6D8 is our goal. So, oh, the 4-1 is too much. I guess. The 4-1 is an A character. Let's double check that. And now it's 4E. 8 4E. Weird. Is that from... Okay. Why would that be? So just to be clear, okay, now the IP is 0. Why would we be getting a 0 IP? I guess I need to follow from the gets call. It is quite confusing. Right, I mean, if we change this to 1E, that should not cause any problems. Right, yeah, it just exited. So making this 1F means we're going to write a 0 into the low byte of the address we're returning to. All right, we will do it after the gets call, I suppose. All right, so what we have in here is all the B's. I don't know what the FC is. I guess that is the original value that was stored in local 8. But we'll keep going. Nope, that fails as well. Why can't I debug this? What is going on? Why can't I step through this one at a time? Okay. I think it's got to be something to do with the particulars of how I'm attaching to it and using PwnDB or Pwn tools. Is it the receive all timeout, I guess? Yeah, that's probably what it is. Okay. Let's take that out. Or let's just detach. Okay. Then do that one. Oops. You know what? I'm gonna not have all those breakpoints in. Got an EOF. Oh, that's fine, because I think I killed it from... Okay. So then, after the string copy, now... do string compare, and that comes back -1, sure. Then right, so we just moved to the call. EAX now has 42 in the low byte. Okay. And that isn't anything. So I guess we need 1E plus that. Yeah. Okay. And it works every time? That is surprising. Only because we need to write 2 bytes. Let's look at it again. Okay, we've done a copy. String compare says no. Now, why has it only written those bytes? Right, how did we get the 8 in there? If we had to write the full byte. Did that one fail? No. Okay, so before we do the call, we can see what we've got. We've already pushed, so ESP plus 4 is, can I do that as a string? No. We want what is it? 1F. Let's do 35 bytes starting at EBP plus 8. Or sorry, EBP minus right. What do we want? I guess we can just copy in the address. Why is that? Oh, 35 ZB. Oh, I see. Yeah, it is saying that. Okay, so why do we? Yeah, we have D806. So, and then this is the target address. Maybe it just happens that what we end up having, but I mean, it should overwrite the full byte. Like I don't think it would ever overwrite a proportional byte. But I guess since it is the same, oh, I see. So we really only need to write the low byte because it's always going to be the correct byte in there for the second to lowest because they're so close in memory. So it's going to try to go to 56 AD, and we want to go to 56 D8. So we only really needed that low byte. Okay. So we can have this work for us. By doing guess we can just do that. Or not. Okay. Can we do a P8? Is that a thing? Yeah. Okay. So really we just need to write the D8 in there. Cool. Well, that was pretty straightforward as far as these things go. I mean, I did take a while on it, but the core of it was, you know, pretty handily straightforward. So we have a 1 byte overflow for the least significant byte of the function that is called. I mean, we could overflow more than that, I'm pretty sure, but no reason to, turns out. I feel like we could overwrite more than that. Or, oh no, that's probably true. Okay. So because we are doing 1F, it should and yeah. And it's 1E here. Okay. I had that swapped around. So yeah, we do get the 1 byte. Okay. I probably could have been a little more seen stuff a little better or whatever, like paid more attention and gotten through this a little faster. So yeah, this is a pretty straightforward one. We didn't really need the loop or anything. Okay. So we'll go to Vuln Chat 2. Oops. I feel like we have done Vuln Chat before. I don't remember how far back it was. Vuln Chat was here. Is this the same? Yeah, TUCTF 2017. These were in just calling a function, so I guess it counts as ROP. In that we are overwriting the return pointer, but it's not really like, yeah, I mean, it just, these things all kind of flow together at some point. And even if you aren't using gadgets necessarily, we have flag.txt. Okay. Sorry, flag.txt. Alright, let's look at Vuln Chat 2. It's 32-bit ELF, dynamically linked, not stripped. Linked to libc. And just has NX enabled, so everything else is off, which is helpful. We don't have to leak addresses if we want to do ROP stuff with the main binary, which could, I mean, but this is going to be a single byte kind of thing, or like a partial overwrite, so we don't have to do a real ROP chain with it. All right, let's look at it in R2. Okay, so we have the standard. It's interesting that we're using the PC Thunk if it's no PIE. It seems to be compiled in a PIE kind of way because we are getting EBX as our offsetter thing. Okay. GC takes us into this do things function, which is going to do a puts call and then a printf call with what? Is there not going to be a parameter on this one? Yeah, we'll have to figure out what EBX is, I guess. And then we can figure out what those strings are. And let's see. Then we'll do a scan in and put a value in local 13, and we will print that out, I guess, with something else. Maybe that prints the address of that, but again, we don't really need to leak anything. Then we do a puts and a sleep for 1 second, and another couple puts and another printf. There's just so much printing in this. And then it's going to read 2D bytes into the buffer at 27 hex, EBP minus 27 hex, which means that we can overflow by, let's see, by 6 bytes, or, well, I guess it's, sorry, we can overflow into the return pointer by 2 bytes. So we can overflow both of these values on the stack. And I guess we push EBP. Oh, sorry, yeah, EBX is what gets saved in local 4. So 27 hex characters in takes us all the way past the saved EBX to where we pushed EBP. Another 4 bytes, and then we got 2 bytes for the return point into the return pointer that we can write. That all sounds fine then. I don't know what it's going to scan in. We'll just have to see. I guess it's a chat program, right? So there's like a expectation that we are interacting with a person through the chat system, and that's the theme of it. What are the, and then there's a print flag function. So we presumably want to write these 2 bytes. All right, let's go ahead and run it and see what we got. Yeah. Okay. So it'll print out a fake flag. Cool. Then we just need deny. Right. It's like, why is there no highlighting? Okay, so then that's our, we can do make it a little more generic. Okay, so then our padding length is, what do we need? 2D minus 2, so 2B. So do receive until, I think it was that. Send my name. Forget what the prompt, yeah. Right, okay. Then there we go. All right, that one was also pretty straightforward. I'm glad that I didn't waste a lot of time on that one like I did on the previous one. Quick read through. We can 15 bytes in input, second scans 2D bytes worth, which holds 20 bytes. Yeah, so they have an overflow and 8672. So we probably could have gotten away with a single byte overflow, or single byte overflowing into the return pointer. We'd still have to overflow by 5 bytes total. Well, more than 5 bytes over, because we have the other variables on the stack. I don't care. Yeah, they write 2B and then a single byte, and that's enough. Okay, cool. So now stack pivoting section. We have another DEF CON Qual's speedrun challenge. See what that does. Okay. Then let's look at speedrun 4. It's 64-bit ELF, statically linked and stripped, of course. I'm not going to make it a simple thing, DEF CON qualifiers. So we've got no PIE, no canary, partial row, and NX, of course. All right, not too shabby. Let's see what we get. It's taking a little while, I guess, because it's statically linked. Of course, tons of functions, understandably. Do we have a main? Yeah. All right, let's see what we get for main. See what that function is. Multi-byte string. R. What is the R in that? I don't. Yeah. MBSR for multi-byte string R. I don't know. To wide character string. Interesting. And so I guess it is. Oh, that's probably not the actual function, but it is a function that. So this is most likely setting up the non-buffering. This is probably calling that function, but is not strictly that function. Okay. Of course, I don't know how it would know that it's calling that function, if only because it's statically linked, so that's going to be an unnamed function inside of the binary. Oof. Maybe it is that function. I mean, this is an annoying level of. Yeah, I feel like this is too much details of the implementation of something like that. So I'm gonna go, and there's canary stuff in here. Whereas I think it said there was no canary. I mean, that was, checksec is not necessarily doing everything perfectly. So it's like a GB. So this is the function where we pass in the string debug. Ooh. It's not too big of a function, but again, it's one of these like, is this a library function? Is it not a library function? Pair against 3D. Okay, let's look at GG. And that loads in that string and passes it to this other function, which is what? Gonna print it out, I guess. Maybe a puts call. Okay, so that's at 410 C30. Okay. 0 pointer to stack parameter in 9. And yeah, why is it? Why does it think there's no function here? That's weird. I do we say? Define function. Define, yeah, df. Doesn't want to, I don't know. Does not want to consider that a function for some reason. Okay. What about this one? This is the library function. Maybe this is reading in. No, it's doing something. And then comparing that against 0. Maybe it is, this is like scanf. And A2I or something. I guess maybe not scanf, but like read 9 characters into that buffer, I guess. Which, sure, that won't overflow. Okay, and then if it is over that much, okay, otherwise we go into this function, which is actually going to scan stuff in, presumably, where it's going to call read and let's see. So 104 is our first parameter, which is the length that we gave. So less than or equal, so we can read in 101 hex bytes. Then we're going to get a buffer that is 100 hex. And we're going to read in theory, 101 bytes into there, 101 hex bytes. And then it'll print it out. I guess this is called a printf. But I think the thing is, right, RSP is minus 110. So we are only overriding RBP. It would seem. And we're going to call leave. Just forget the specific semantics of leave. What Linux distro do I use? Says Linus didn't make Linux. I am using Arch Linux. And I guess maybe you get this a lot, but what do you mean with your username about Linus not making Linux? Okay, so that maybe is... So we can control ESP a little bit. And we could set, so we can control EBP, which, because we're doing the leave instruction, is going to move EBP into, or RBP into RSP. But what we are doing is controlling I see. So this first leave will copy the current value of RBP back into RSP. So it just sort of does the reverse of that one. Then it is going to pop the top of the stack into EBP, or RBP in this case. So the thing that we had pushed here, but this is the one where we can control the low byte of it. So now the low byte of it gets in, the thing that we can control the low byte of gets into the RBP register as a result of the second set of behaviors of the leave instruction. Then we immediately return to this leave instruction, and this one is going to move our controlled value into ESP. So then we can control ESP, and that can control what we return to, because the return is going to kind of pop from ESP. So, or just, I don't know, I should just say SP and BP. Okay, so we can control that. Then we can find some gadgets. I think we have NX is enabled, so we can't just jump to shellcode on the stack, but we could set ESP into our buffer, which will have a bunch of ROP gadget addresses in order to do the ROP chain that we want to do. I think that's what we can achieve. It's just a troll name, but I have read this on Quora. Sure. I mean, well, okay, yeah. Everybody loves to, not everybody, but certainly Mr. Stallman likes to bring up the fact that the GNU tool chain and all of these other tools that live in the user space of the Linux operating system are generally speaking instrumental to it working. You can absolutely use the kernel without GNU. There are alternative user spaces to go on. But yeah, GCC, all of that, like, certainly for a very long time, the GNU set of tools was, or the whole GNU, I guess they like to, Stallman at least likes to call it an operating system, but it's the user space portion, was the only way to use Linux and not just have a kernel. So it's not a incorrect point. But that's, I don't know. I would say it's not like all of that GNU stuff was created for Linux, for the Linux kernel. It was ported to the Linux kernel from existing Unix operating systems, right? That's my understanding. Because I think it was like already in existence. And so I would argue that the GNU stuff is operating system agnostic, or it's, you know, it's like Unix like or POSIX like in its targeting. There's obviously stuff to allow it to work with Windows, for example. But in that sense, then the thing that we think of as Linux rather than Unix, rather than Solaris or one of the BSDs or something, is the thing that was originally created by Linus. So I think, you know, it's one of those like, people like to make that point only to bring up the fact that the GNU tools are a important part of the whole ecosystem, and not because it's actually incorrect to say that what differentiates Linux from other operating systems is the thing that was originally created by Linus and continues to be run at his direction. So I don't know. Let's see. We want to yeah, let's do this with GDB because we've got no PIE, so I can just sort of work out the offsets as necessary. Then what languages do I use mostly? I don't know, a variety, I guess. For this stuff, for the sort of Pwn related stuff and in the hacking practice stuff, it's a lot of Python because the tools that I use are written in Python. So Pwn tools and Anger are both Python libraries. I am writing an x86 instruction decoder in C right now, and I plan to rewrite it in Rust once I have a more complete version of it. And it is not my job. I'm kind of between jobs right now. The last thing I've written that is close to being in a job capacity, I was writing a Clojure code, which I really like. I would love to have more opportunity to write Clojure because I like Lisp style languages. And my last like real job, I was writing a lot of Ruby and JavaScript because I was working at a boot camp where we taught Ruby and JavaScript for a web sort of web development full stack kind of curriculum. And previous to that, I did a bunch of C++ for game development. So it's been all over the place. Yeah. At this point, I just, you know, sort of take whatever language seems appropriate for a particular use case. A lot of times it's based around what tools or existing software I need to or want to use, and use the languages that they work with. But, you know, I need to do more learning of Rust and Go, since those seem to be coming more heavily into play in sort of InfoSec stuff. Yeah, I've never actually worked in any InfoSec career, and I guess cyber is really more the like government military term, at least here in the United States. And I've never worked in a cyber kind of job either. But I would like to work in, you know, maybe vulnerability development kind of stuff, like the stuff where you are finding these kinds of exploits in real software and then writing proof of concept exploits and stuff of that nature. Yeah, web development is, I mean, I would say it's hot right now, but you know, it's been hot for I don't know, a couple decades, right? So that's where you'd probably get more money and maybe have more job opportunities than InfoSec. There's a lot of need for InfoSec jobs. I think if you go look around, like they always say, like, oh, there's, you know, a million job, like InfoSec jobs needed or whatever, how they say it. But, you know, they have their estimates around hiring and stuff. But I think the reality is, like, companies are more willing to put money into developers than security related folks, because the developer work more obviously translates to revenue, and so they'll hire more of them and they'll potentially pay more depending on where you're at. Kind of like if you're in the US and you're in San Francisco, Austin, New York, Seattle, one of those places, you can get paid really well for it. And there's going to be you know, well, it's a mix of like a lot of places hiring and then also a lot of people around that are trying to get jobs. So there's a lot of competition for it as well. But at the same time, like 90+% of all the students that we taught got jobs out of it, and jobs that paid pretty well for a first year kind of person, not even having a college degree in programming. But like I don't know how to get a job at cyber related companies, like what degrees you need, and if you need any, where do you get them? Because definitely not college or university. That part I don't know. I did not go to university, so I'm mostly self-taught, and I don't anticipate going back to university. There are definitely cybersecurity or infosec related degrees. Like you can get a bachelor's and a master's degree in that stuff. I don't know what is entailed in those degrees. To be honest, I haven't really looked at the curriculums, and I don't know if that's more something that you would go to as a practitioner or something that you would go for if you were looking more in towards management and some of the like less very in the like weeds of the technical stuff. Because I want to say like, oh, somebody goes in and they have like a role that's non-technical or whatever, because I think that can be a very judgy kind of terminology to use. But there's a lot of career paths and stuff in InfoSec that are more around management, more around interacting with people at the company that you work at, or understanding threats and dealing with that. Like there's a lot of stuff that's not necessarily, oh, I'm typing code in all the time, or oh, I'm analyzing and reverse engineering something, or I am ensuring that things are patched properly, or testing through like pen testing and red teaming and all that. So maybe that's what the degrees are more for, but they could also just be like degrees that'll get you these skills. At the same time, the skills that I'm applying, like I think if you went and you did a standard computer science degree or computer engineering, might be a little more focused on this kind of thing, but like they'll both get you some way towards this. It's just a matter of my understanding, at least, because again, I did not go to university. What you're going to get out of it is highly dependent on what you end up doing on your own time while you're there, which is part of why I'm like, I don't know. I think at this point and again, this is very United States centric, because I know that not every country works this way, but in the US, it's extremely expensive to go to university, and people take really large loans to do that. And so if you're looking at spending $50,000, $100,000, whatever it ends up costing these days, it would be a really good idea to determine if you couldn't achieve that same education in another fashion. That granted, no bank is going to give you a loan for $50,000 to do a self-education process, even if that education would be more useful, because the student loans cannot be discharged in bankruptcy, so they know that they'll get that money back, and they're also guaranteed by the federal government. So you can definitely get $50 or $100,000 or $200,000 or whatever you need to go to university and be saddled with that debt for the rest of your life. Whereas you cannot get some money to go your own path of learning and, really make the most out of that. It's definitely, in that side of things, is absolutely a giant scam. But it's not right. University is not a waste of time, but it can be a waste of time. Let's put it that way, right? If you go and you don't have a declared major, or you major in something that turns out you don't like at all, or you major in something and you simply don't spend any of your time building on what that is, you can come out of it and not really have made much progress in terms of advancing your own skills. And I don't know, there's definitely other benefits you get, presumably. Again, talking from not having the experience, but like, I don't want to discount the like things that aren't skills for a career that you can get out of going to university, but I do question whether those things are worth the amount of money that you have to pay for it, I guess. Because if if it's about finding yourself and meeting cool people and having a great time, could you do that for less money? Is a interesting open question. But if you don't have access to, thousands of dollars in order to spend that time not going to a job, then it's a much, it's a harder question. Because it can be very difficult to gain those skills in your time after working full time at some whatever kind of job you can get without a college degree. Like, I worked at Subway a lot. I worked at other fast food restaurants a lot. And I would certainly spend time putzing around on the computer after work most days, because that's sort of my lifestyle, I guess. So that sort of worked out for me, but not everybody is willing to spend most of their free time, working on stuff rather than enjoying their life doing things that aren't necessarily building a skill, I guess. And I, granted, I wasn't looking at it like, oh, I need to do this to build skills or whatever, but it's just like, it's not everybody's priority versus, maybe you have a family, maybe you like to spend time with your friends more. I don't know. It just sucks that university is only, like, the pathways are very difficult in terms of either you get saddled with a lot of debt, or you must already have a bunch of money to be able to achieve the amount of free time necessary to learn a skill in a reasonable amount of time. So you do this as a hobby in your free time. I mean, that's sort of how I did it. I got started really early though. Like, I did a lot of this messing around and learning stuff in a very uncoordinated and not very like rapid manner, but I did it through middle school and high school and stuff. And like, I imagine coming out of high school, even though I would look back on that and say I was not a very good coder, I was further along than, a lot of people, certainly like midway into university. And it was just a very uneven kind of thing. Like, I definitely couldn't have written like a nicely designed program to do thing X, and I didn't know anything really about data structures and algorithms, but I could like reverse engineer a network protocol to figure out how to make a bot for a certain web game. Kind of like, if I had the motivation, I could figure this stuff out, basically. So it was it makes it hard to put stuff on a resume, I guess, when it's so scattered like that. And so that's a difficulty that you should probably bear in mind if you're just sort of doing this on your your own is like, how much do you want to structure it along the lines of curriculum that you can find online? Because these days there's all kinds of those online courses, and I think a lot of them are probably high quality. But if you need to sort of balance that with what is motivating to you. And I found like I learn the most when I have a particular project or goal that I want to do, and I will simply look stuff up related to that. And my biggest asset is probably what would be very generously called tenacity, and more pessimistically called stubbornness, and just not giving up when I probably should. I will spend far too long hunting down a bug or something, because I don't. It doesn't. It sits in my brain, and I can't give up on, like, why does the thing not work? Why doesn't it? Like, even if you watch some of these streams, like there's one of the things I was doing just earlier on this stream was a thing where I got it working, and then I was like, well, it didn't work how I thought it was going to work, so why? So then I spent time trying to figure out why it didn't work, even though I had succeeded in the goal. It's the understanding and feeling like there aren't any mystery spots that really drives me sometimes. If you have a project or a goal, it would be way easier to learn, but you're stuck. Yeah, that's the flip side of being well motivated by a particular goal or project, is sometimes not, like, you can be in this valley of not feeling like anything you want to do, or not, just feeling like, oh, there's nothing I want to do. Like, at least I definitely get in those moods sometimes, and they can last weeks and weeks and weeks, months, and I don't know. The best advice that I have for that, because I don't think that I've like really figured out a definite plan for myself to get out of those funks, is like, try to do little things. And it's sort of like, maybe, if I'm feeling real depressed for a long time and I let a bunch of like garbage fill up in my apartment or whatever, maybe just cleaning one little thing starts me on the path towards feeling like, okay, well, maybe I'll clean a slightly bigger thing now. And then, even if the thing that you're doing right now is not like some goal that you're really into, it might get you in a point where your brain is now like, oh, I could do that, like just sort of kickstarting your motivation center or something. Do challenges on Code Forces for fun, and also Code Wars. I think I've heard of Code Wars. I don't know what Code Forces is, but I'm presuming it's like small coding challenges. And so that's, I've never really done the competitive stuff. I always feel like I am not going to do very well in them. The pending project I was working on, a web crawler in C++. So, I mean, that seems like a nice project, but you don't know how to finish. Can you give more details on like what you are thinking about in terms of what it means to finish? Q# coding contest. I've never even heard of Q#. Quantum development kit. Oh, for making quantum apps? Yeah, I don't have a quantum computer. I didn't realize there were meaningful quantum computers out there. This is like, it's all simulated, so you are coding for what they think a quantum computer is going to turn out to be like. I guess they might be close enough now. Click problem set. There we go. Or is it problem set on this specific thing? Yeah, I mean, way out of my depth in any sort of quantum computing situation. And I don't, I mean, um, okay. Yeah, I mean, I don't even know if this is like hard so much as you just really have to understand how quantum computing works. Because I don't really know enough about qubits and yeah. This is the sort of thing that makes me feel like, oh, if we are 10 years from now and quantum computing is the the standard for how people do programming, which seems like an absurd thing. Like I don't think the industry would be able to switch that quickly. But let's say we get to that point where everything is built on top of quantum computing. Like I don't know. I don't know if I'll be in a position to understand the low level stuff. I think the way that programming works, there's always going to be higher levels of abstraction, so you could just work on that. But I don't know. Yeah, I'm also not a very math focused kind of person, and I feel like that's you're absolutely right about the like challenges in competitive programming. It's a lot of implement this algorithm, um, and that uh, doesn't really interest me all that much. Um, if there's an algorithm I need to implement for a particular purpose, that's fine, but it's I kind of, in order to feel motivated by it, I need to have that context where I can see why using this algorithm is the right way to go. Like, I had a project that involves sort of recreating the rsync algorithm, which generates a checksum for a certain chunk of data starting at every single byte in a file. And so if you have 1,000 byte file, you generate 1,000 checksums. And then, you need to be able to store that in a way that allows you to quickly search through those checksums if I want to cache that data. And so I can use a certain algorithm for that, or data structure rather. I could use a prefix tree to store that and have a minimal space usage because probably I'll have hundreds of millions of these hashes if it's a large, 100 megabyte file or whatever. And I want to reduce so those sorts of like having a context where I know why I would use this algorithm, why that would give me the benefit, not just the like, oh, it's got these, big O time and space complexity characteristics to it, abstracted from any real reason. Yeah, it's it's helpful to know about the algorithm stuff, but I'm not going to like write one independent of any kind of use case, I guess. And then doing it in a competitive scenario also doesn't really interest me. I feel like I tend to shy away from competition and feel like I'm not going to do very well in it in the first place. Yeah, if you need to learn something for a purpose, then learn it. What I would say is don't even consider it lazy if you don't want to write code that doesn't have a purpose. I don't think that's necessarily lazy. That's just expressing a preference. I prefer to have a particular task that I want to solve, and then I will figure out what I need to do to solve that. Unmotivated if you can't solve the problem. I think, and this is, you know, purely for myself. For a long time, I would think about myself as lazy and unmotivated and all that, because I was in a position of needing to work on stuff that was not interesting to me in any capacity. So this was when I was working at fast food restaurants. I, even though I was on my own, and you know, it would be real bad if I lost my job. I found it very difficult to go to work sometimes, just because is kind of a mind-numbing experience and not motivating at all. But then over time, in talking with therapists and stuff, like coming to a realization that some of the stuff I'm willing to do, like this hacking stuff, would probably be mind-numbing to a lot of people, and I can put quite a lot of time into it if I have a challenge that is interesting to me. So I think motivation is not a you might be unmotivated for in a particular direction, but find the things where you are motivated and just go down that path. Because this is like my fundamental theorem that I work on right now, is the things that I get good at are the things that I'm going to spend a lot of time on. I can't, like, fundamentally, I'm not going to be good at a skill if I don't put a lot of time into that. And the things that I'm going to put a lot of time into are the things that I have some sort of innate motivation towards. I just enjoy doing it, which I've found tends to be these sort of low-level hacking kind of things, where it feels like a puzzle mystery to solve, and maybe that'll stop being as interesting to me in the future, and then I'll have to find something else. But trying to force myself to like be motivated to a thing because I think, oh, that end goal seems really good, I fall into that trap a lot, and it's just never worked out. So if that feels like where you are at, I would say, you know, try to be cognizant of when you are sort of focusing on the end goal at the expense of the process, because the process is what's going to take the most amount of time. And if that's not enjoyable, you're probably not going to force yourself through it long enough to get to the process. Some people are real good at forcing themselves to do a thing that they don't like. And, you know, if you aren't that sort of person, and I certainly am not, then it's just no use trying to act like you are that sort of person, I guess. So, and I, you know, it's probably good to also just come to the mindset that not being that sort of person is not a problem. It's not a judgment on you. It's not a judgment on me that I can't force myself to do a lot of stuff that I don't like to do just because it seems like the end goal out of that is going to be good. Which, you know, it has its downsides for sure. I don't spend a lot of time working out because it's not enjoyable right now. Even though that end goal seems very enticing. But maybe I'll get to a point where I'm mentally like enjoying the process of working out. I don't know. It's still going to be physically annoying. I've done it. I've been in that position where I've been the person to just try to push myself. Okay, I will make myself go to the gym, you know, X number of days a week or whatever. And I can do that for a couple months. And then something will come up, something will happen, and I will switch off of that cycle. And it's annoying, but I don't know. I don't know what to do about that. So I'm gonna, you know, just keep focusing on the things that I am motivated towards, and try to trust that that becomes useful to me. Thanks for your time. Oh, appreciate it. I mean, I'm always happy to talk about stuff. And you can, come in anytime if you want to talk. I try to stream basically every day. Thanks for the follow, by the way. I stream different stuff. So tomorrow is going to be coding on the x86 instruction decoder in C. Then I sort of ping pong back and forth between that and the hacking practice throughout the week. And then on the weekends I do these try hack me rooms. So that's more web pen testing kind of focused stuff. So if you want to get, I mean, there's a lot of people on streaming on Twitch. If you want to see that kind of content, I would recommend Optional CTF. He does that stuff all the time. So if you want to see that side of InfoSec, that's always good. But yeah, if you're more in the coding side of things, maybe this low level stuff is helpful. I don't know. Thanks for joining and chatting, and feel free to stick around while I puzzle over what I need to do here. I think I need to get a buffer that's 101 hex bytes, and that low hex byte will be something to set ESP. So let's see. I need to first say, yeah, payload is A times 101. Code that. Oh no, it's 100, and then let's do it as just 0 for right now. Cool. Yeah, feel free to stick around. Let's see. So that'll be the payload that has the overflow. So we'll overflow this byte, and 00 is not going to be the right value, but we'll just have to see what that is for right now. But first we need to say how many bytes we're going to input, and we have to input 101 hex just as an integer though. So binary.process gives us a program or an object that controls the program. So then we can say proc.read until, receive until say question mark. Maybe it's say question mark and new line. And then we can proc.send line the string version of 101 hex. And then GJ takes us to, and then it's going to print out what do you have to say for yourself. So we can receive until self question mark /n, and then we can send payload as a new line, and I'm going to put a pause in here. So the pause is going to let me connect to it in GDB. I haven't actually run the program, so let's run that real quick and make sure that the receive until kind of stuff is what I anticipate it should be. So yeah, so we're going to basically start the program and then say, give me all of the text until and including say question mark and the new line character basically. And then we will reply with 101 hex converted into decimal, which is what is that, 256 or sorry, 257. Yeah, 257 bytes. And then it's going to question us, okay, what do you have to say for yourself, question mark, and then there'll be a /n as well. So we'll receive all of that text. We don't actually care about it, so we don't even print it out. And then we'll send our payload, which is 256 A's, followed by a null byte. And the way that they are reading stuff in, I believe they're calling the read function. So that means it will, or it's calling fread rather. So fread is going to take a pointer. No, it's not. it's not fread. It is this read, the Linux version, which takes a file descriptor number, so they're just passing in 0, and then it takes a buffer pointer, which is the like stack variable -100, and then a count, which is the 257. So it's going to read 257 bytes from standard in into this buffer that's only 256 bytes long. Okay, so then I'll run the exploit. It's going to wait for me to connect in GDB. I should have I forgot where I was at. So, because there's no symbols in this binary, so I can't tell GDB, like, show me the disassembly of this particular function. So I'm going to have to ask it to show me disassembly starting from a certain address, and I did not write down what those addresses are. We'll just make a little temporary buffer here, a little scratch pad kind of thing. So I think it's all in this function here. So gh, oops, there we go. So we want to, and then in this sub function is where it actually does the read call. So we'll go into there, and where do I want to put it? We can put it after the read call. So this address. Oops. There we go. Okay. No. Just do it once. Right. Okay. And I guess I will get this function address. So we'll call this like read func. That address, and we'll have I don't know, prompt func. It's going to be this one, in case I want to do, like, tell GDB to disassemble these functions so I can find more breakpoints. I'll just have those there. Okay. Then maybe if we need to run it again, I'll open another terminal and keep radar and GDB open. Oh no, GDB does not have that. But we can do attach 3285. Oh, could not attach. Oh, because it is. Oof. That's going to be annoying. It's got an alarm set up. So the alarm signal triggers after some number of seconds, and it's not very long before it says, hey, yeah, so it's not permitted because the program had actually already closed by the time I got around to it, because basically if I run the program, let me say 1, 2, 3, 4, 5 seconds, basically it will close out. So I want to, how do I want to deal with that? I'm going to say like GDB signal. I want to just have it catch the signal or handle it. And okay, so we'll say handle sig alarm ignore. ALRM ignore. Okay, so it's not going to stop and it's not going to pass it to the program. And I think that might be enough. We need to attach 3299. Still have to attach before. Okay, so it got the alarm signal. But we did hit the part, our breakpoint. So I think we can continue debugging in GDB even though technically the program is basically quit. Let's see. Yeah. Or no, because we didn't step forward anything, huh? Yeah. Oh. Let's see if I can get enough information from this. So RSP. Let's put it on the yeah, I'd have to be all right. So keep that as a scratch. $17, I think. No. Oh yeah, yeah. This is the first one. Okay. What is it doing? All right. Then GH. So I won't be able to do much debugging in GDB. I mean, maybe there's a better way to prevent it from actually exiting the program. But I don't know how to do that. To be honest. Info signals, that's what I want. Oh wow. Didn't need all of them actually. So sig VT alarm is not what I want. Sig alarm. Still set to not to pass it to the program. Yeah, there's a, I mean, you can set a bunch of custom signals, I guess. But these are the main real ones. There's just a lot of them. Okay, so I don't know. I'm probably not going to be able to do a lot of debugging in GDB with my current ability. I don't know how to prevent that sig alarm from breaking things unless I go in and knock out the call to the alarm function, which sets up the timer. And I could certainly do that if it comes down to it. But I'm going to try to avoid it for right now. So what I want to do is actually put my breakpoint here, I think. So okay, yeah. Then just go to that address. Okay. So we're gonna only break on the return. which should allow me to see what the effect of the leave is. And I can, even though the program will probably have quit by that point, I can look at, it's probably 3.3 something. I can look at what's in this, what's on the stack, because that's really what I need to know, is what offset I should put to be on the stack. 4.2, no. Okay, so in RBP, we've written that null byte, and so it was 88 something, and we need to, apparently that does go into the beginning somewhere in our string, so that's nice. But we don't have much insight into where in our string that is, but I mean, the fact that 00 is already in our string is probably good enough. I just need to figure out where it is. So how do we generate, how did I do it before? We can, is this what I want? I want to generate a De Bruijn sequence, but and I know there's a radar command for it, but I don't remember what that command name is. Oh, I want the cheat sheet. Oh, it's rag2. Or just -h. Okay. De Bruijn pattern offset, and let's see. I guess it's just, I don't know why it says prepend, but I guess it prepends it to whatever else it's going to output. Okay. Sounds good. I'll still be here. All right, so I'll put this as no, I don't want so I'll put as ASCII. Where is raw bytes? Okay. So this will be our input sequence. And oh, I'm spelling it wrong. De Bruijn. I don't know how to pronounce that. Okay. Yeah. So then if we run the exploit with that, we can pinpoint where 00 starts in that string. Okay, so it starts at this. Then we say rag to Q. Can we also put R? No. I think we need to do 41, 41, 41. $72, and I guess $73, $74. Wow. I mean, what is it looking for? Why does it? $128 seems like. Okay, so oops, let's double check that by saying A times 127 26 plus B times 120 130, so that'll be 256 still. Okay, so that's still all B's. Yeah, whatever that count was is not right. Or okay, I guess I just needed to do that. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 minus whatever. Or 8 plus no. $112. Let's do padding plus let's see. That's all zeros now. Is it different each time somehow? Yeah, that time it had it in the spot. There's just something to do with okay, so it's gonna be difficult if we can't actually predict where in the string it's gonna be. Okay, it's there that time. M, N, yeah. Then it's at R. So the difference between these that one. So it's a 16 byte difference. And then this time it's way off in here. Interesting. Is that part of the sequence? Yeah. It's up here, DABE, APF. So that's a difference of 79. ECB. I think it was that, maybe. No. A, B, B, A, B, C, A, B, D. I see. A, B, C, A, B. So that's 80 character difference, yeah. Ooh. How do I deal with that then? And that's back to that address. And then here, I mean, we could just try it until something works. Okay, so we want to get our ROP chain going, and we need to do a ROP chain that calls system in 64-bit. I'm gonna just, since I'm kind of low on time at this point, look at, what did I do? 07 static, probably feed me 16. Yeah. What did I do for gadgets? So we create bin/sh. Could look for that string, see if we can encode it, and then we just need EBX. So EAX has to be the syscall number that will pop, and then EBX has to be the string address that we're writing to, or that we will write bin/sh to, or the address of an existing bin/sh. And then ECX EDX will be null. Okay. So let's use romp gadget and strings with it. Oh, yeah. String. Okay. There's a bin, but I want to start learning assembly. Do you recommend a book or a website? What have I recommended in the past related to this? I need to like keep these resources listed somewhere. I felt like there's a thing that I saw related to assembly the other day, by which I mean weeks ago at this point, but let me look if I maybe made a bookmark of it. How did I learn? Just sort of tooling around reverse engineering programs, so a lot of like game related stuff. Like, what are some games that I did a little bit of reversing on back in the day? Like EVE Online. There was a lot of the source code for that is in Python, and I wanted to be able to like get the original Python source code because there's a Python decompiler that ended up only working partially, but one of the things that they had was like a check so that you couldn't modify the files, and my approach to being able to get the decompiled stuff was to write my own Python code that they would run. Yeah. So, well, that's one thing you could look at. Godbolt.org it's mostly for developers who want to like understand the low level behavior of their. Maybe I should have read that, but If you want to understand what your source code is going to turn into in a whole bunch of different compilers in different settings, so we could do O0, for example, and get the so this could absolutely be a good resource for learning assembly. I mean, it's mostly targeted at people that sort of know assembly and are just trying to understand the minutia of the performance of their program. So maybe if you're a game developer or somebody else working on really high performance algorithms and very like vectorized loops and stuff, and you want to figure out, hey, why did my code stop being vectorized automatically or whatever by the compiler? But if you just want to put in simple bits of C code and then see what the assembly is, and it will highlight what each line sort of relates to, and you can start with O0, where everything will be much more clear in how it relates. That can definitely get you part of the way of I mean, there will be scenarios that you won't necessarily see through this, right? But because like it's not necessarily going to do all kinds of different calling conventions and stuff, but you could also look at it in like just non x86, or sorry, well, yeah, you could look at it in other instruction sets for sure, but I meant like not 32-bit. So you could look at the old school style. Apparently in this one it outputs in AT&T syntax. It's kind of annoying, but or what is, wait a second, so now it's using the 32-bit registers and stuff, and you could see how that might differ. Calling conventions are a little bit different on 32-bit and stuff like that. So this is a good tool just for interacting and getting a better sense of those are like core ones to learn. Push and move are really handy. It's like what you really want is something that shows you related to memory and stuff, because you know you can read what the like push instruction does, and I have you can look at this website, which is a sort of a database of x86 instructions that has been pulled from the like the PDF of the Intel manual, and I use it pretty often to just look up individual instructions to get the details. But these details aren't really going to give you that sort of intuitive sense of how the stack memory works and stuff like that, and then how that interacts with move and all that. So you want a resource that really focuses on these broader concerns. Let me look for if I have anything in my links. Applied reverse engineering, maybe that's a good one. The problem is I've also not like read a ton of these pages that I've actually linked for myself. Whoops, don't want to leave the Twitch page. But maybe, oh yeah, I like this guy's stuff. So let's I'll link you this one as well. I've unfortunately lost all my chat because I have not been working it. Apparently there's a .engineering, and Twitch's link code assumes a fixed limit to the length of the TLD, but that's a real URL, reverse.engineering. And so I've read some of this guy's blogs before and enjoyed his stuff. I don't know that I've actually gone through this particular resource, but it is going to go into stuff like how the stack works, which is really when you're reading the instructions, it's not just about knowing what this instruction says to do. It's about having a vision in your head of what the memory would look like. And I mean, you can see it in GDB, and this is using the Jeff extensions to GDB. So if you're on Linux and you want to use GDB, I would recommend getting either Pwn Debug, which is an alternative to Jeff, which is GEF rather. But they're both add-ons to GDB, and they give you a bunch more information for if you are looking at, generally it's for when you don't have source code, but more specifically it's showing you all of the low level details. Like here, it just, every time it prints out all the registers, and it prints out a portion of the stack starting at ESP, or in this case RSP, as well as what instructions are going to operate. So probably you want to pair looking at stuff in, maybe throw some C code in Godbolt and then compile it and run it in GDB with one of these add-ons, Jeff or Pwn Debug, PWNDBG, and then pair up like, okay, what do the registers look like as I step through these instructions one at a time, and what does the stack memory look like as I do that? And that's how you want to build up your intuition around what is going on with the memory that is being worked with by these instructions. Because understanding what push does really is, just understanding it at the concept of, okay, it adds something to the stack. Like you need to have a deeper kind of intuition for how the stack works in order to have the full understanding of it, so that when you're reading that push instruction as the program goes, or you're just looking at it in a reverse engineering tool and you're trying to imagine what the program would be doing, these things all sort of come together. And then learning about what all the registers are that you have available in x86 is a good idea. There's only a couple that are like special purpose. So there's like RBP is mostly special purpose, but it can be used for arbitrary stuff. And then RSP and RIP are the like dedicated special purpose registers. RSP is always pointing to where your stack is. So if you ever have a push and a pop instruction, it implicitly depends on what RSP has. And then RIP is the address of the next instruction of code that you're going to execute. So that's basically how it tracks where in the program you are. So like we're at this 400 BD1, and you can see it's printing out 400 BD1 is the return instruction that we are attempting to execute. It's not actually executing because the program has died because of the alarm thing, but in theory you could execute it and then it would pop to this next instruction. And the reason it does that is because the value that RSP points to, because RSP has a memory address in it, and the value at that memory address is 400C44. And so that says, oh, this is where the next instruction is that we're going to execute. So again, it's like the understanding of how the memory works and how the stack and the rest of memory work pairs with what the instructions are doing. I think you would have a very difficult time if you're just focusing on the instructions. So I want to get that sort of hammer that home. And so I think try to read that resource and mess around with stuff in Godbolt and GDB for yourself. And just know that, like, I would say I was able to make meaningful work. We'll be back later if you are still on. Are you live tomorrow, by the way? Yeah, I try to stream basically every day, starting around the same time. So like 2 hours and 40 minutes prior to now, which is like 8:30 p.m. my time, because I'm actually out over in Asia right now. But yeah, basically try to stream every day. And so feel free to hit me up tomorrow. The one last piece of advice I have, just in terms of learning assembly stuff, is like, what has helped me is to sort of relax my expectation that I need to know all the details to be able to make meaningful progress in terms of reversing things or accomplishing a particular task with it. So when I was talking about like working on the Eve online game thing, I had to turn off a check that was like, okay, have they modified the files basically? And they just had like an if statement basically in the code. And I was able to tool around looking for like strings that, like log messages and stuff that would say, oh, now we're going to check the flag on this or check whether or not you've modified the files or something. And I was able to sort of hone in on a bit of code that I didn't understand at all what was going on in that assembly code back then, but I knew like a jump instruction or a jump not equals instruction or whatever is like basically an if statement kind of thing. And so I was able to turn that into a jump equals or a jump or just a nop so it didn't jump at all. And I was able to make use of that to basically hack the Eve client, even though like I had very little understanding of what was actually going on in that assembly code. So just know that you can get pretty far without having like a really broad understanding of assembly, I would say. And in fact, I'm constantly looking up instructions that I may not have seen before, or I just don't remember the details of how they work. So, and I'm still, I'm able to like significantly reverse engineer programs at this point, not like some awesome people that reverse engineer game consoles and entire like the whole Mario 64 ROM and stuff, but definitely enough to be able to do real work at this point. And I'm still would say I know only a small portion of the instruction set, for example. So it's not about knowing all the details is my second most important point. Anyways, thanks for joining, man, and chatting with me and indulging me in all my opinions about stuff. Hopefully I'll see you again sometime. Okay. I mean, if you loved it, dude, I'd say don't give up on it, man. Like, yeah, that's the reason that I'm doing this right now is I realized I was like kind of burnt out on working on the school. Working at the coding boot camp, and so I had to sort of take a break from that. I left that job and I was trying to think on what I wanted to do next, and I realized like how much I loved doing the sort of like little game hacking stuff that I had done before. And I say little in the sense that like they weren't very like large projects, but they were really exciting to me. And then so I decided, okay, I'm just going to follow that path of what I had a lot of fun doing and continuing on and learning about exploit stuff, and like that's all been incredibly fun. So yeah, don't give up on it, man. Just keep going. I do have a Discord. I don't like not a Discord channel, but like I have a Discord account. But let's see if I'm rarely logged into it, so it's not always a great place to contact me. I think maybe I have the app on my phone, so if you send me a message, I'll probably see it. Let me see. Okay, I guess that's copied my name. So yeah, that's my handle and the number associated with it. So feel free to send me like a friend request or whatever it is. Again, I don't use Discord very much, but you're always welcome to ping me. And yeah, cool. Thanks for being a friend. And Teagle Built, thanks for the follow. If you're still around, appreciate it. Yeah, we'll see if I can. We've got people watching on the stream now, so we'll see if I can actually hack a thing. But it's been weeks since I've done a ROP chain, and it's like not burned into my memory. I'm gonna streaming on YouTube would get more people. That is a good idea. I hadn't thought about doing it on YouTube. I have a YouTube channel technically through the like regular YouTube account that I have, And I was planning to upload all my recorded videos from Twitch because I've downloaded them in case Twitch gets rid of them. So yeah, it like this sort of stuff doesn't seem like it has a big following on Twitch. There's definitely hacking related stuff, but not this sort of like binary exploitation, low level kind of stuff for the most part. There's I don't know, a few things that are in that category, but I don't see many people working on these like pwnables challenges, which is unfortunate because I would love to watch people that are more experienced than me. So yeah, a lot more game dev. I mean, there's a lot of software development stuff going on, but not as much like the one person on Twitch that I would say does stuff in this realm, but I haven't seen him like really working on exploit development is Gamozo Labs. But he's really fun to watch. He's amazing coder, and I would love to take the time to use some of the software that he's built related to fuzzing, which is a good way to find vulnerabilities to then exploit. But at the same time, it's like he might stream for 12 hours in a day and he's coding that entire time. And for me to be able to understand what he's coded and be able to like, you know, compile it and then write a program that makes use of it or something would take me 5 times as long as that. And in that time, he's now made 5 more 12-hour streams or whatever. Like it trying to keep up with him is impossible from my experience level, let's say. But he's a lot of fun to watch. Is that who you were talking about, or is there somebody else? Or is that other person on YouTube? Okay, so we got a ROP chain. I'll just have to switch out all the Kindred Sec. Oh, I don't know this person. Yeah, analyzing some stuff. Like I see he's got IDA open, I think. No, that's not IDA. Is it? Maybe it's IDA not in the graph view. But you know, he's definitely analyzing malware stuff. So reverse engineering is really cool for my, you know, mindset. Code browser, never heard of that. Yeah, thank you for the link, man. I don't know. Yeah, sometimes people only have like a couple videos, and I don't know if that's because they don't keep their videos up, or maybe he just hasn't been streaming very much. But I will definitely got the follow on there, so I'll hear if he does more videos. Another person that oh yeah, I was about to say George Hotz. Yeah, I mean, I wish he did more of the hacking stuff. He's in the past done some streams that are actually in that, and it was a lot of fun to watch him. But I don't know, man. I'm not going to watch him cooking, or it was probably interesting, whatever thing he was doing with the COVID stuff and all that. But it was kind of outside of my. I don't know anything about biology and all that. Yeah, and you know, obviously the car AI stuff, which I don't know, just doesn't interest me. But I try to watch his streams when he does it because he is a very entertaining person, and if I can sway him to doing more hacking stuff, I think that would always be interesting to me. I tried to do a update or whatever, like did a pull request for his project, the Kira tool that's like the reverse debugging program, just to like have it work with more recent QEMU. But I don't think that ever got merged in. I don't know. I don't think he spends a lot of time on that stuff anymore. Which is too bad from my perspective, but whatever. I mean, if he's kind of done a lot of it and then got bored with it, who am I to judge? Yeah, there's definitely some other people, but I most of the people I follow on Twitch are like software development people. So it's fun to watch, but it's also like, I don't know, it's probably also really hard to get into somebody working on a hacking thing, because these are, you're so deep in the specifics of some particular project or whatever. Oh, this is the first time somebody's asked about the keyboard. I think it is a random sort of Logitech that is, I don't know if it's technically a mechanical keyboard, but it's got the like clackiness to it. Let me see. I don't want that. It's a Logitech G610 keyboard. Nothing fancy. The other one that I had was a used like generic ass PC keyboard that I got for $5. So I went to like DEF CON last year and I took a like burner laptop. So I went to like a used PC place and got a tiny little laptop, and they had a bin of like mice and keyboards. So I just picked up whatever was in there, because the laptop was so small that I needed to have a different keyboard in order to realistically use it. And so I still have that around, and it's a nice clacky keyboard as well. But again, it's like $5. Like, I think all the keyboard fans would be maybe a little put off by the grody-ness of it. But it's got history to it in that it's probably used at some company for 10 years and then donated. Not very esteemed history for sure. Yeah, I haven't gotten into the keyboard stuff too much. So I don't have any like the cherry whatever variety people like, or I guess that's all personal taste, but I don't have any fancy keys or keycaps or any of that. Yeah, maybe one day. Some of them look really nice. The ones that look really nice to me are like the white ones that have maybe a little bit of pastel color or something, but then I know that they're going to have my finger grease on them, and that's going to look bad. I have to constantly keep cleaning them so they don't sort of yellow out or whatever. And then I have to look at it and be like, oh, my finger grease. Razer Black Widow Ultimate. Nice. I feel like I've had some Razer stuff before. I mean, good gaming stuff. My setup right now is sort of gamer-y because I went and had somebody build a computer for me. And like here in Thailand, they have a bunch of companies that do gamer hardware. They're like a PC store, but it's clearly very oriented towards people that want to do gaming. So I like gave them all my specs for the computer I wanted, and then they added a bunch of RGB lights and stuff. Super unnecessary from my point of view, but whatever. Yeah, I use art. Yeah, this is my main OS. I'm SSH'd into like an Ubuntu box just for this challenge, just for working on the nightmare stuff. But given that I didn't have any requirements from work because I'm not working on anything, I was I'm just gonna use Arch as much as I because I'm just gonna use Linux. And I guess I've been like Linux as my main OS for the past year and a half at this point. I've got it on my laptop and now on my desktop as well. And i3, yeah. I have i3 on my laptop, And then here on the desktop, I'm actually using Sway because I decided to go for Wayland, and it seems fine as well. I have not put any time into customizing it, like with all the i3, bar, or no, spaces or whatever. There's, the variant that lets you like put a little distance between all the windows so you can see your background and have a nice, like, the stuff that everybody posts to Reddit of their really nice looking setups, and they do look nice. I have not put it in any of the time to customize that. Like this toolbar up here, the sway bar, these are the default colors. The only thing I did was like add another clock so that I can see the Seattle time and my local time and stuff, and took out a few things that weren't being used. But yeah, that's one of those things that I always tell myself I'll get around to doing, and then I guess it's a matter of motivation. I'm not that motivated to make it look nicer. If somebody were to come along and say, "Hey, I made your whole thing look nicer," I'd be appreciative of it. I'm not like, I'm not against it looking nicer, but I'm apparently am not into it enough to put in the time. So yeah, I'm not like an elitist, like, oh, if you spend your time trying to, make your desktop look really nice or whatever, then you aren't doing real work. Like that seems silly, but so far I have not put in that time. Yeah, I'm basically like, I'm too distracted with trying to get through what I'm working on right now. And like, so, when I sit down to the computer, I've already got a thing or a couple of different things in mind of what I'm going to do. And it just never is one of the things like, oh, fix, your configuration of something. Which is, unfortunate because there's definitely, I don't know, like I need to set up a better like tracking of my dot files and stuff. There are little things that I should spend the time on that are sort of the computer equivalent of cleaning up around the house, and I don't let myself do it, or I don't make myself do it, I guess. Do you use Vim only like for writing code with different languages? Primarily I use Emacs. I'm using Vim on this because I'm just SSH'd into a little virtual machine and I didn't bother to install Emacs with all the settings that I use. But I switched over from Vim to Emacs with the evil mode, like, I don't know, 6 months ago or something. Mostly because I decided that I wanted my wanted my editor to have like a good basis for its software, and Vim is very usable, but Vim script kind of sucks for software development, and so even in the best of cases, it's a lot of things that are kind of hacked together, and it feels like things are on a more reasonable architecture and all that when it comes to plugins and add-ons being implemented for Emacs instead, if that makes sense. Like, I said that in kind of a rambly way, but basically, if you want to use your editor and combine a bunch of different add-ons and stuff, it seems like it's a better experience with Emacs because it's written in a language that is much more extensible and all that. But I absolutely refuse to learn like how to do stuff in the standard Emacs mode. Vim is absolutely the better way to interact with an editor, in my opinion. And so I use it with the evil mode stuff, and that works for me. I actually use something called Doom Emacs, which basically sets it up for you. Yeah, GVim with a bunch of extensions, and that's sort of how I did it as well. And it's just like, it's, you can make it work, but it always felt like there were, I don't know why I just decided that it was like too much hassle around Vim script and stuff. But as you know, as I said earlier, I'm kind of a fan of Lisp kind of languages, so I appreciate eLisp, and certainly working with the closure code that I've been working on. Can maybe pull that up on another. Let's see. Can I hide this? So if I'm doing something in closure, I can say like define a function foo. It's got x and y parameters. Then I can do a let and like I don't know, keys foo of x, and then more stuff, right? And I can like add things and other stuff, and see how it's like automatically fixing all the parentheses and indenting stuff for me. Like I didn't have to type anything special. I went in here, hit insert, hit enter, and more stuff, and it puts the parentheses where they are. And I'm sure there's a way to like, there's maybe an extension for Vim to do that, but it feels much more appropriate for a Lisp kind of language. The level of fixing of parens and stuff is like critical for using a Lisp style language, because you are constantly having open and close paren situations, and like I can just remove stuff and it will figure, it figures stuff out based on indentation properly and all that. So like it's deleting in parentheses when I delete the lines that have the open parens. I'm going to show the gvim. I mean, you can, if you have it pushed up to GitHub or another like public Git or online repository of whatever sort, I'm happy to check it out and see what you got. I can certainly play around with it on my computer in Vim. But yeah, I don't know. I'm still, generally happy to use Vim. It's the main thing is, having all the Vim shortcuts for switching modes and for moving around and edit, the Vim like command language basically is the critical and most meaningful component of Vim to me. And it turns out you can have that in other programs as well. So if I ever have to use an IDE like a Visual Studio or whatever, I absolutely try to get the Vim mode going for that as well. So I guess at my heart, I'm still a Vim user. I just have sort of strayed from using Vim itself. Okay. So we need to find all these gadgets. So binary is speedrun, no jump. And so we'll get all those gadgets and we'll grep for it's going to be rect. Oh, I can't use this. This is 32-bit. Okay. So we need all right, it's simpler at least in 64-bit. So we need a pop RDX, RAX, RDI, RSI. Yeah, that's it, I guess. And then a move, the right what where thing, I guess. So let's see if we have a pop RDX. We do. Okay, why don't we do okay. Just gonna make this look a little nicer. What is that? Oh, that's the address we are writing to. All right, we'll pick an address. And then okay, I think we'll leave it in there. So our pop RDX is this address. What is our pop RAX? This guy. And RDI. RSI. Move. Keyword pointer. I think it was keyword pointer. RDX. RAX. No. Can we put Yeah, we need to write all of racks, I'm pretty sure. Right? Okay. I hope no. Okay, so what are we moving into? Can we say, okay, so we can do, why didn't I find this one before? Oh, it's probably because it was like, these are special. Okay, so this is my move keyword pointer into RDX, or you know what I'm saying. And then syscall. Be that one. Okay. This might actually work then. Given certain a certain amount of luck, because it does seem like we jump into different parts of this string at different times, but it seemed like the one that came up multiple times was starting here. So we'll pad with this much, and then we'll have our ROP chain. And we need to figure out an address that we can write to. So let's save. Oh, I need to fix this. Start with that. Okay. Let's run GDB again. And set the breakpoint, I guess. I don't know that it matters. Okay. Oh, we have a vsyscall. Interesting. So, I mean, we could take advantage of that, but this is at fixed addresses, I'm pretty sure. So we can write to somewhere within this page, seems like. Yeah, let's assume that. Let's run it again. Oh, okay. Yeah, same map. So just write it somewhere in there. Just do it. Whatever, it doesn't really matter, I would say, because we're about to just pop the shell anyways. I think that is everything. So then stuff needs to come at the end, and we do oops, geez. Where am I at? Go here. Maybe we'll just say padding is equal to that string. How about we set this up, and then I guess we can set it here, and we don't need this anymore. Okay, so payload is going to be equal to padding, and then for E in ROP chain, padding plus equals P64 of E, and, or sorry, payload is that, and then payload plus equals B times 256 minus len payload. So second, like ending the padding after the ROP chain, and then we add on the null byte to do the overwrite, and do interactive after that. In theory, this is sufficient. Okay. I'm going to take out the pause. So sometimes it must be hitting into our code. But it's not spawning the shell. Oops. Okay, so how can I debug that? All right, I guess I'm gonna disable the alarm call. Maybe it's this first thing here. I mean, it doesn't seem like it would be call. You can look at GG, but I feel like that's just puts, or maybe printf. Yeah. Okay, so what does this first function do? I would think that just turns off buffering. Oh, maybe if you do debug. Yeah, what is 40E840? Oh, that does a string compare. think it does strength compare. I don't know. Okay, what's in the first function? Maybe okay, so it calls alarm before it does the right call. Does it tell me? Oh, I can do call stack, right? Dash K. Alright, so where would we when we got the alarm call? We're at 49E87. Or 8E7 rather. No? Okay. About 1239. No? How are these the addresses then? Okay, let's see. GG calling into GA, calls 42419. Okay. But there's nothing up here. Okay. Can I do 0, 1, 2, 4, 1, 2, 3, 9? I think it's 4, 0, 1, 2, 3, 9. Okay. Can you show me where 401239? Good Christ. Is this actual code? Yeah. this the function that contains it? One zero. Wait, that should be 401239. Oh, trying to find the call to alarm is difficult. I guess this is the call, and this stuff doesn't matter, but that, I mean, these look like the parameters that you would send to like set vbuff or something. And what is at PZ? No. PX. PX what? Quad words? (6b) doesn't print anything. There's nothing at that memory address. 6b97a0. Alright, well, let's start the program in GDB, I guess. No, this is gonna alarm, right? Yeah. Then what is the? Guess let's put it on C400 C46. I'll wait 5 seconds. Okay. Now let's wait after that call. See if that one was the one that eventually calls alarm. Doesn't seem like it. Maybe the next one is. Found this website to upload photos online and took a screenshot of them. Sure. Yeah, if you want to send it over. I don't know where the alarm gets set then. Is this the alarm call? We're calling it with 0. Oh no, this should be the read call. Why haven't we triggered the alarm yet? I don't understand that. So, alarm gets called before the write call for the first thing. So, did this print something out just now? I don't see it having printed anything out. Oh, I feel like this is the call. How did I miss this? Let me go into this. Okay, so just give me a second. I don't know why it doesn't want to download your image. Yeah, but it's like the PNG file or whatever is just coming back with a 404. If you want to use like Imager or something, that seems fine to me. But for some reason, this one is not finding anything. I don't know if it's how I am attempting to access it. Okay. Yeah, that one found. Um, so yeah, you have the one of the like file browser extensions. There's a bunch of, I don't know which one that is. Nerd Tree, yeah, that's, I've heard good things about that one. I've never been that, like, I don't think I ended up ever using those. Just did a lot of typing it in manually, or in Emacs I just like just do space and then various, you know, I can do fuzzy searching through that, and that ends up working pretty well. But having the tree is also useful, especially in bigger projects. So cool. Yeah, I like the color set, and you know, it's nice crisp font and all that. Yeah, seems good. I don't know that I have a lot to comment on it, but it seems good. Um, do you have like built-in like syntax checking stuff that'll tell you if you've typed something incorrectly or whatever, like linter kind of integration? Nice. Yeah. That's the sort of stuff that is like, yeah, autocomplete is good. All of that stuff is, especially for C++, pretty critical. Right, with You Complete Me. Yeah. I think that's what I ended up using. I used a lot of the plugins from this guy. I think that's how you put it. Yeah. Shogo? I don't know. Is Japanese. I think it's Japanese. I don't know how to pronounce it, but maybe I guess I use Dioplete instead of You Complete Me. But mostly like the Dyn thing I found to be a very handy plugin manager. And there's another one that's like general purpose. Maybe it's, I guess D-Night is like a newer version of it, but um, some other thing that he had created that sort of puts a bunch of stuff together. So yeah, I liked a lot of his stuff. I don't know. It seems like, I mean, you can do a lot of stuff with Vim. That's for certain. For certain. Okay, so I guess this is the call. That sets the alarm to 5, so we want to patch this. Nice. Compile and run code in the terminal. Yeah, if you can integrate in your like build process so that it's in your IDE, you get a lot of benefits from that. It's definitely like, I don't hate the stuff that you get in the larger IDEs, especially like, Sea Lion and Visual Studio, the like original version. I don't have a lot of experience with VS Code, but I suppose for stuff other than maybe C++, like if you're doing Windows development in C++ or certainly anything in .NET, just using Visual Studio is probably the way to go because there's so many features integrated with it, and being able to do your builds and like get the error list that connects directly to your code. I don't know. I mean, I used it for many years. Yeah, it's definitely a big program. It's definitely a resource intensive program. But I didn't hate it. It's not my preference. Yeah, but it'll I mean, maybe they're doing better in recent years. I don't know. They've definitely cut down on the installer annoyance, and maybe they're also concerned about the just being a really bulky program to run at runtime, like CPU and memory usage. I don't know though. They might have decided that's a battle they cannot win at this point. Okay, so I'm gonna just have XXD. So I need to find where this is. Maybe I'll look for that string. Can I... What is like a Linux hex editor? Command line. I mean, if I can only print stuff, then it's not really a hex editor, is it? More of a hex viewer. Okay. Can I do a search? I don't think I can actually modify stuff with this, it seems like. Oh, I mean, I could maybe pipe it and stuff and generate it back from the. It just feels like too much, man. Oh, I can. Okay. I guess I can try it in Vim. So what am I looking for? Let's look for E8 528C. Or, oh, it's giving me 2 byte pieces. So maybe it's 52E8. E852. Hmm. C0400. Hmm. Oh, I guess I should look for 528C. There we go. Okay, so what if we did maybe 65,000 seconds? Oh, this is not going to work. No. I don't know if this is going to work anymore. Yeah. Vim doesn't like to set binary. Ah, okay. So let's see. Nightmare modules 17 DC qual speedrun. How do I have it do a command first? Let me just do Vim and then set binary. Okay. And it was, I think, 528C. Okay, still works. And now we are moving a lot more. Okay, so then if we S-trace it, we get alarm called with 65,000 seconds. So we've got a lot more time before the alarm kicks in. That was interesting. I've never modified a binary in that fashion before with a command line hex editor tool, or through Vim, I guess, technically. All right, and then I want to so one of these, I think it's probably the ret then, yeah. All right. So we're going to jump to gibberish and it's going to load that into, yeah, so segfault from that. And I wonder why that was the segfault, because it seems like we would be trying to access all B's, 42, 44, whatever. But we got segfault trying to access that address. It's a bit weird. That's fine. Just run it again. And okay, so now we are actually hitting our shellcode, it seems like. So we pop RSI. So, wait, oh, we jumped into the middle of our shellcode? Feels like, yeah. Right. What is going on? Oh. Oops. Guess I can do it in a loop at this point. Okay, maybe. Okay, pop racks is still not the beginning of our shellcode, huh? What we could do, I wonder if there's a NOP. There is NOP ret. So let's fill out everything with NOP ret. And then we have a much better chance of actually hitting stuff. Never done a like NOP sled through ROP. Okay, so how long is this? It is 112 bytes divided by 8. It's 14, so we can fit 14 in there. Okay. Or I actually don't want to. I want to pad it. Let's go ahead and put it at the end of the sequence. So okay, so now what we're going to do is build our ROP chain, which I have, in a very uninspired way, just called chain, the result of chaining together all of these as 8-byte, address pointers, basically. Then we figure out how long that is in bytes and how much space we have in our 256 byte buffer that we can put before that. So then let's see. Let's actually just print that out. So we can do 18 exactly. Okay, that's good. I didn't think there was going to be a problem since they're like all powers of 2, but it's always going to be safe. So then we basically put 18 of these NOP addresses in front, and so we have kind of a 1 in 8 chance of hitting the beginning of one of these NOP point addresses, or somewhere in the chain. But the chain is pretty far to the end, at this point, or it's at the very end of where it possibly could be. So most likely we're going to hit one of these NOP return addresses, or NOP chain ROP chain thing. ROP chain sled, ROP NOP sled chain. I don't know. It's very late and I'm getting a little bit loopy. So then, yeah, and that'll eventually slide us right down into the actual logic. So maybe this should ensure and more likely. Hey, that worked the second time. Sweet. So yeah, there we go. Okay. That was an interesting technique that I had sort of vaguely thought about it because we have such a big buffer and we know that we don't have exact control over where we start in that buffer. And the first thought is like, oh, let's do a NOP sled. But then I was like, well, we're not actually executing from the stack, so a NOP sled isn't going to help, which is true. The NOP sled by itself wouldn't help, but if you can generate it as a ROP chain, as long as you hit at the beginning of one of those addresses, then you get the same impact as a NOP sled. I wonder if that's what they ended up doing. The RET gadget slide. Yeah, so I guess they ended up doing the same thing. So what is their RET? Oh, you didn't even really need a NOP. That makes sense. If you just do a RET address, you'll just keep retting. You'll just keep returning to the next address on your new version of the stack. So that makes sense. Cool. It's the same impact though, because you still need 8 bytes. So you need to hit at the beginning of one of those addresses or your return is going to be all off. But a 1 in 8 chance feels pretty good to me. So, and it worked quite quickly on my machine. Yeah, that was a fun one. It took me a while, but I didn't get super frustrated through the whole thing. I felt like I had ideas for how to deal with stuff, other than the alarm being kind of annoying. Which I think if I had clued into the idea of doing the RET slide / my NOP RET slide earlier, then the whole messing around with the alarm wouldn't have been necessary at all. But there you have it. Yeah. What do they do? They have a move, which they do it the opposite way with RDX moving into keyword pointer RX, but basically the same ROP chain that I had for doing the syscall to exec VE. Right on. Well, this has been a lot longer than I anticipated, but I was having fun chatting with people, chatting with Linus Didn't Make Linux, and having fun working on this particular challenge. So I feel okay. We got through these 3 today, and tomorrow we're going to go back to working on the x86 instruction decoder. It's gonna be interesting because we're gonna start adding a new chunk of opcodes to support, I guess. So we'll probably have to refactor things a little bit. And then Wednesday we will come right back to working on the Nightmare series, and we'll see if we can get through the other 3 in this stack pivoting category, and just keep going through. I've never done signal ROP, SROP, I guess. So that'll be interesting to deal with. And yeah, and then I don't even know what the CSU and RET to CSU is, so we'll have to figure that out when we get there. RET to system implies returning to the system function, which I feel like we have done before, but maybe it's like a category of making sure that you have things, you have to do some particular thing to have stuff set up on the stack or in the right registers for the call to system to work. We'll find out as we go through these in the intervening weeks and then eventually get on to heap exploitation. So as always, thank you to everybody for watching and chatting with me, and I'll be back tomorrow.